highlighters, stuff like fencing after this one. All right, type 2, fencing questions. So remember, it's still regressions where we come up with the equations. Okay. I give you a little help here. Start with a diagram of the area to be enclosed. That's very important. I would suggest you do that. And there's no one size fits all here when it comes to making your diagram. You're just going to have to read carefully. I will tell you this, that quite often you don't have to fence in all 4 sides. And it's always rectangular, right? Rectangular areas. These types of questions will usually ask for the dimensions. And by dimensions, I mean length and width. When you hear that, you should remember it's length and width that we're talking about. That would result in the maximum area, to be enclosed. So I wish I had something prepared to show you this, but it ends up being like if you were to fence in, if you only have a certain amount of fencing available, right? You can, like if you make it like this, let's say you have, 200 and 200 feet. This is 100 and this is 100, right? So in total, think about it this way: 200 and 200, that's 400, 500, 600 feet of fencing, right? But you could also make it if you have a space is not an issue, you just have an X number of amount of fencing available, you could do this, right? Where you make how am I going to do this one? 600 feet, right? So let's say this is 250, 250, right? 250, 250. That's already 500 feet. So you have 100 feet left to do the ends like that, right? So you can choose how you want to spread this out. And the reality is that there is one size for all 4, right? All 4 dimensions, I guess, length and width, that will maximize the area, will get you the most you can possibly fence in. That's the reality, okay? So that's what we're going to explore. What dimensions will give me the biggest area that I can fence in? So this type is more challenging than the other regression types, as it will not give you a starting point, right? This is the key here. This type will not give you a starting point. That's why this is challenging. Some students are like, if you don't have this on your study sheet, you're going to be like, I don't know even how to start. I'm going to skip this one, but don't, right? Because you can do it. You need to read the question carefully and create a diagram before you create a table, okay? Create a diagram before you create a table. Here are some examples of diagrams that you're going to possibly encounter. So these are the steps that's boxed in here. This is kind of like if you follow these steps, you will be able to do it every single time. Create a diagram, okay? So what does that look like? Does it look like this? Is it just one area fenced in like this? Or is it this scenario where there's an existing structure, no fencing required along this side, for example? That actually allows you to make a bigger area, right? Because you don't need to fence in this side of that enclosure. Are you making several smaller subdivisions within the enclosure? So this is like a farmer question, right? You need your chickens, your cattle, sheep, and so forth in each enclosure. You want them to be the same amount, right? So that's what you're going to encounter there. So let's second would be write out the equation of the perimeter or area depending on what you're given. Okay, so in this particular case, the perimeter would be 2L plus 2W. Okay. Perimeter would be 2L plus 2W. And so basically the perimeter is the fencing fencing available, right, would have to be spread out over 2 times length plus 2 times width. Versus here, no fencing required along this edge here. You don't need fencing there. Here, the perimeter would be just length. You just need to cover this other side here plus 2 widths. So fencing is length plus 2 width. In this scenario here, I will add at the top making subdivisions. Okay, that's when you make subdivisions. So watch this. This is going to be a bit controversial because the perimeter, you know it as the distance around, right? But in this case, we're also using that fencing that we have, right, to make the subdivision. So we count that in. So normally, right, you have nothing in between there. It would just be that big rectangle on the outside. But now you need to say, hey, to make this happen, you need 2 lengths plus, watch this, there's 2 widths on the outside, but you got to count the ones inside as well. So 1, 2, 3, 4, 5, 6. 6 widths. So the fencing will have to be spread out amongst 2L plus 6W. Okay. And what else do I want to say here? That this is key, right? Once you draw what is it that this question is wants me to figure out, then you write out the fencing which you will be given. Okay, this will be given. I'll write that underneath. And once you have that, we use this to get us started. Okay. So second step, write out the equation of the perimeter or area depending on what you're given. Normally, I will give you the perimeter. Third step is isolate for length or width. You're going to isolate for length or width using the equation in step 2. Okay. What does it say there? I usually isolate for length. Okay. And so let's walk through this. This is important. If I wanted to figure out L here, okay, if I wanted to isolate L, then I have to go like this. It's going to be a little crowded here. I'm just going to leave it for now. I'm just going to give you an example. Let's go with the example here. So let's say that you have 500 feet of fencing available, and you decided that, right, we have this scenario here in our hands. Make sure you follow along, right? Let's say it's just a regular rectangle that we're fencing in. So you're like, okay, based on that diagram, in this particular case, I need to say 2 L's plus 2 W's. So then the question tells you, hey, you have 500 feet available of fencing, and you need to relate it like that. I say this, 2L, and then this one comes over subtracting. So you go 500 feet, so 500 minus 2W. And to completely isolate L. It's not isolated yet. We divide it by 2. And we cancel out the 2's here. So length is 500 minus 2W. But watch what I do, because students forget that there are invisible brackets, like whatever happens at the top needs to happen first, right? I usually isolate for length. You may isolate for width. It doesn't matter. Okay? Now that you've done this, right, you can create a table like this. Let the dependent variable be 100, 200, 300, or 50, 150, 200. You decide. I will show you that. But it just looks like this: length, width, area. And then perform a regression using quadreg. Okay. Which one here is my dependent variable? The one that's on its own is the independent. So in this case, that is my dependent variable. So I will make a note here. W is the dependent variable. Okay, very important. In this case, the way I isolate it for length, width is the dependent variable. It's like the y, right? Y and x, right? Oh, sorry, I completely got this wrong. But it's an easy fix. W is actually the independent variable, guys. I didn't have enough coffee this morning. You know how x is usually the independent variable? Remember, y is equal to mx plus b. So it's the same scenario. This is my y, quote unquote, and w is therefore the x. So it's the independent. Sorry about that. Anyway, so now we can perform a regression, and here we go. I'm about to start the math, so right now just follow me. So let's say you want to relate length and area, and let's say we do square feet, right? It's not always going to be feet, it might be meters. Right? Or you could relate area, square feet, and width, same as before. You know, before we had price and number of items sold, right? So you can relate both of them to the area if you wanted to. And at the top here, the vertex, you get, in this case, length and max area. And in this case here, the vertex would give you the width and the max area. It depends on what you put in L1 and L2. So before it was price, number of items sold, profit is this times this, right? Now it's just length, width, area is length times width. So the same idea. This always goes into L2, right? Always. Okay, and either one of these goes into L1, you decide. Make sure A is not equal to 0, because then you have a linear equation in your hands there. Okay, let's give this a try now. So it's a little overwhelming, but I think if I break it down, we do a couple of examples, you'll be okay. So let's go here. Let's try the first one. You ready? Calculators. Classic. You can't miss that this is fencing. So on page 63, you're a contractor and you have 600 meters of fencing available. Okay, 600 meters of fencing available. So you only have that much to go around. And you're enclosing a rectangular area. Okay. It is adjacent to an existing garage, so no fencing required along that side. Okay, no fencing required along that one side. Sketch this scenario. Okay, so I will suggest you do this. Make the structure that it's up against be the length. So this is the length of my rectangle, and here you have a structure, which is the garage. Okay, no fencing here. So I usually do have something like this going on there. So don't put an L on that side of the rectangle. You don't need it. And this is width and width. So you do need the ends to be fenced in and the long side as well. And the idea is you can use as much as you need. The garage doesn't really have a limit. You can keep going and use that to cover the long side. Okay. Write the equation relating the dimensions and the perimeter. Okay. So we'll do this. Fencing is going to be length plus 2W. So the amount of fencing you have needs to be spread out along the long side and two short sides. So you have how much fencing? 600. That's L plus W. Which one do I normally isolate? I normally isolate for length. So I will say this. Length is here. The 2W here will come over subtracting. Okay. So I go 600 minus 2W. You're actually done here because length doesn't have a 2 in front of it. It's isolated. You don't need to divide by 2 like before, right, on that example. So this is what I would be after. This is relating length and width using the perimeter, quote unquote, or the number of fencing, the amount of fencing available. That is key, right? Key for creating table. Okay, that is the key point, right? Your diagram, and you do this. Hey, you have this much fencing, length plus 2 width. This is based on my diagram. Okay, create a table with at least 3 rows because we need 3 points. So we go length, width, and then we go area, which is length times width. In this case, W is the independent. I just want to make sure I didn't get independent variable. Okay, so that means that you get to plug in values here of your choice. You choose. I normally go 10, 20, 30. It doesn't matter. Okay, so let's go 20, 40, and 60. Random values, right? Random picks. Right? This is important. I don't go too big of a number, but I also don't go 1, 2, 3. You could do 1, 2, 3, but then sometimes the changes are very subtle, it's very small. You don't see how it's going to change anything. So here we go. Once you've picked this, Y, it's all W is independent. And so my independent variable, you get to pick whatever you want. It's kind of like picking your X values and determining the Y values now. Okay, so how do we find length? Here it is. This is the key right here. it'd be 600 minus 2 W's, right? That's what it's saying. 600 minus 2 W. And so that's 600 minus 40, right? So that'd be 560. Next, 600 minus 2, what's W in this case? I picked 40. So it's minus 2 times 40. So it's 600 minus 80, that's 520. One more time, 600 minus 2 times W. In this case, W is 60. Right? So 2 times 60 is 120. So that would be 480. And can I do, I think you'll be all right if I did this, right? I'm just showing you that I'm inserting these numbers that you picked. So remember, you can go 5, 10, 30, whatever you want. I choose to pick a pattern because then you should also see a pattern. I don't know if you see that you're dropping, right, 40 every time in this case. So it's kind of like you can tell that you're doing things right, but it doesn't matter. Okay, and then here we go, 560 times 20, 520 times 40. So from now on, everything is the same as type 1. It was just the beginning that was different. You know, the random picks actually throw students off. It's like, how do I get this, but now what? Well, you need to put in values for the independent variable. So let's go ahead and do this, enter this. I'm just going to read a little further. Watch what it says here. Determine the equation relating the length. So I'll put the length into L1 and the area into L2. And stat calc quadratic regression. Think of area. Area is square footage, right? It is a quadratic function. I'm going to go stat, edit, clear whatever I have in there. And I'm going to go 560, 520. Oops, my bad. Let's try this again. 560, 520, 480 for L1. L2 gets this one here, right? The 560 times 20. 520 times 40. And 480 times 60. And I'm going to write these numbers down. And run your regression, stat, calc. I can probably just copy paste, but there it is. So y is equal to negative 0.5x squared plus 300x. That is relating. So now this can give you every single length related to the area that comes from it. Okay. Another quick check I want you to do. Watch this. If L is 560 and both widths are 20, right? So there's 560, 20, and 20. That adds up to 600, right? That's your fencing. That's how much fencing you have. So you should be able to replicate that. Let's keep going. What would be the greatest area that can be enclosed, right? We're looking for, look for vertex, right? Look for vertex in that case. So we're going to go second, trace, max. And this should also not be pointing up. This curve is pointing up on you. something is wrong, right? You don't have a maximum area. You have the minimum area. So let's see how we can graph this. Zoom 9. I'm going to go zoom 9. And then window, change the x min to -5, y min to -5. I'm going to hit graph at this point. So I do see a significant amount. I'm going to clear the 9,000. I don't need it. I just need to increase my y max and my x max a little bit. X max, I'm going to go 800. Y max, I'm going to go 40,000. Oh, still not enough. So 50,000 it is. There we go. That does the trick. Okay. So I went Y max 50,000 and X max I went 800. Okay. And you cannot have negative areas and you cannot have negative length, right? So we're assuming it's quadrant 1 again. So second trace 4 for the max. Let's go ahead and find it. There it is. 299.99. Right? It sounds like a retail store, right? But that's definitely 300 rounded. So that'd be 345,000. And if you think about it, this is length. And this is not width, but area. Okay? That's what you just found. You found actually the maximum area. So what's the greatest area? Greatest area that can be enclosed is 45,000. We are in meters, right? Square meters. Watch out for the units, right? So the biggest area you can possibly enclose with in this scenario with having the garage as one of the sides is 45,000 square feet. Square meters, sorry. What dimensions would yield the maximum area? What dimensions? Dimensions, right? What's the length and what is the width? That's basically what is being asked here. The length you already know. Length is 300 meters. Right? We already know that from our previous. Right? The width, watch what I'm going to do. I'm going to just figure out area divided by length. That's the easiest way of doing it. So you take 45,000 divided by 300, and that would be 150. Okay. So if you have a point and you want to find the other variable, just go area divided by length. Just like before, profit divided by price gives you the number of items. Area divided by length gives you the width, right? So there you have it. Those are my dimensions, right? So I'm just going to make a statement here. Dimensions of 300 meters by 150 meters will maximize area. The enclosed area. We're almost done here. With me to the other side. Create a graph relating the length and the area. I thought you'd never ask. aerial length, and area. Area is in squared meters. You got to make sure you get that, right? So at the top, y-axis. So that's out of the way. And what do I need again? I need my vertex, which I know vertex is 345,000. Notice how big the numbers get, right? The x-intercepts would be 0, 0, as well as the other one. What other one, right? We're going to find the other one. So go ahead and find it with me. We're going to let y2 equal to 0. Hit graph. And then let's go find. If you're not sure if the first one is, you can go ahead and double check. But so 600, 0 is the one on the far right. That's the other x-intercept. Vertex, x-intercepts, and the y-intercept is given away by the first x-intercept. It's also 0, 0, so that's an easy one there. So I need to go all the way to 600. So let's see here. 1, 2, 3, 4, 5, 6. Hey, if I go up by 100, that's perfect. Perfect. And I need to go all the way to 45,000. So I'm going to go 1,000, 2,000, 3,000, 4,000, 5,000, right? So that works pretty good. I allow you to do this if you want. You skip and just label every other one. Right, so that's 20,000, 30,000, 40,000. That would tell me that you're consistent. You just gotta make sure you don't mix those up, right? You don't put the like 50,000 all of a sudden here, because then I would check and I would say, wait a minute, you're not going up consistently by the same amount, right? So you lose marks. And obviously 0 and 0. And so that's our first point there. 600 zeros way over here. And 345,000. So this would be 50,000 way up here. So 45,000 is right in between these two. You do that and that. Y is equal to negative 0.5x squared plus 300x. Boom, you're done. You know what? Domain and range. Take a minute or two. Tell me what the domain and range. Actually write it down. If you're not too confident, just lightly write it in. But what would you say right now would be the domain and range in this situation? You can ask your neighbor. Got it? 0, 600. 1 mark, easy mark, right? 0, all the way to 45,000 for my y variable. Done. 2 marks right there, just like that. Determine the equation relating the width and the area. Let's. I feel like you get it already at this point, but let's walk through it. The equation relating the width and the area. Stat, calc, quad reg. Let's go through the motions anyways here. Stat. I feel like if I don't, it's gonna bite me later on. So we're gonna do width and area. I gotta go back for a bit here. I'm not gonna change the areas. I'm just now gonna type in the width for L1. Right, 20, 40, 60. Go back to that page. And just, I'm going to go to my main screen and just go copy paste. You run this again and it'll be a different equation. It should be. And there it is. negative 2x squared plus 600x. And if I don't specify, listen carefully, if I don't specify what equation, which ones I want you to relate, you choose. I don't care. Because ultimately I'm going to ask you what's the maximum area to be enclosed, and it doesn't matter which one you use, you get the same maximum area for either one of them. Okay? So this particular one, every single point tells me these two pieces of information. This width would give you that particular area. Okay? So this one is different. What is the maximum area? Would it be the same as an E? Yeah, it should be. So let's try to get this going for us. Zoom 9. I'm going to change that to -5 for my mins, right? And I still need to increase my Y max. I know it's going to be 45,000. So my Y max is going to 50 right away. My X max, I'm going to go 800 just like before. And there it is. Second trace 4 to get my max. Ooh, I'm way off grid. Watch here. I'm in the negatives. Oh, there it is. Popped up. Left side. A second to find it. It did. The maximum area, second trace 5. Max. So that gives me 150, 45,000. This is the width, and that's the max area. Still 45,000. Max area is 45,000 square meters. Same as in question E, right? What dimensions would result in the maximum area? The same it is. So in this case, let's pretend like we hadn't done the previous one yet. So you'd say, hey, the width I know is 150. The length, I'm going to go area divided by width because those are the two pieces that I know. So it's 45,000 divided by 150. And voila, right? Same as F, right? Same as found in F, okay? So I want you to see that it doesn't matter how you do it, it's all connected, right? So this would have been like, hey, relate the width and the area and go through that, right? You still get the same. Okay. That's it for today, guys. Your brain is probably spinning. Don't blame you. So let's see what I can assign. I'm only going to assign you 2 questions. I'm going to see here real quick. I want you to do, this is the rabbits, right? The rabbits. Yeah, I'm going to do that one. Homework is page 66. And I want to have one where '66 and '67. 2 questions. Okay.